All right, so we're talking about the empirical rule from section 3.3. The goal is to be able to represent data using the empirical rule. So for the empirical rule is for all bell-shaped distributions. That's the key. So for any quantitative data, so that's our data that has numbers, quantitative data set with roughly a bell-shaped distribution, we have the following rule that applies. And you can see it visually represented to the right and then represented using text to the left. So looking at our bell-shaped curve here, you'll notice we put everything in relationship to the mean of the data set. So recall that x bar means the mean, and that lowercase s means the standard deviation. So we can expect that 68% of all the observations in our data set lie within one standard deviation of the mean. And then 95% of the observations would lie within 2 standard deviations. And then almost all of the observations, or 99.7%, would lie within 3 standard deviations of the mean. So we'll look at an example. We have PCBs, industrial pollutants, are known to be carcinogens and a great danger to natural ecosystems. As a result of several studies, this should say studies, BCP production was banned in the U.S. in 1979 by the Stockholm Convention on Persistent Organic Pollutants in 2001. One study published in 1972 is titled The Effects of Environmental Pollutants Upon Animals Other Than Man. And in this study, 60 Anacapa pelican eggs were collected and measured for their shell thickness in millimeters and concentrations of PCBs in parts per million. And the PCB concentrations are presented in this table. So the question is it reasonable to apply the empirical rule to estimate the percentages of the observations that lie within 1, 2, and 3 standard deviations to either side of the mean? So going back up to our initial requirement to apply the standard deviation or the empirical rule, is the data quantitative and is it bell-shaped? Well, thankfully we have this frequency distribution, and you can see that the table or the data is actually bell-shaped, and the numbers, the data is a set of numbers, so that's quantitative. So then our answer is yes. Yes, because the distribution of the sample is roughly bell-shaped. So then part B says use the empirical rule to estimate the percentages of observations that lie within 1, 2, and 3 standard deviations to either side of the mean. So that just goes back to the rule, and we can say that 90 or 68% of observations will lie within 1 standard deviation of the mean. The next number, so these are numbers that you'll come to memorize. 95% within 2 standard deviations, and then 99.7% within 3. I'm just going to use S for standard deviation. And again, this, the empirical rule, is an estimate. So that's to keep in mind. This is just what we would estimate to be true. Part C, we'll have to flip back and forth, is asking us for the actual percentages of observations that lie within 1, 2, and 3 standard deviations of the mean. So we'll go back. The best way to do this would be using Microsoft Excel and to enter each of these data points and then and sort least to greatest and then highlight from least to greatest, and then it'll actually tell you the count in the bottom right corner of your screen. But I've already done the counting for you, so we'll just write those numbers in here. So you're literally counting within 1 standard deviation of the mean. So we first need to figure out what that is. And so to do that, the best method is to actually draw it out. So in the middle, we always have our mean, which we use the symbol X bar, and we know our mean is 206.5, and then we do X bar plus S, followed by X bar plus 2S, and then X bar plus 3S. And then we'll go below and subtract 1 standard deviation, and then subtract 2 standard deviations, and then subtract 3 standard deviations. So you take out your calculator and do 206.5, our standard deviation here. Let's see if they gave it to us. Okay, so they didn't give us our standard deviation. Our next number would be, we would add, when we add our standard deviation, we would get 272.9, 339.3. So we can just easily figure that out. So it's 66.4 is our standard deviation, which you can find again if in Microsoft Excel if you entered all that data and used our formula. And then 3 standard deviations above would be 405.7. 1 standard deviation below, if we subtract, so 206.5 minus 66.4 would give us 140. And then minus 66.4 from there would be 73.6. And then 7.2. So looking at our data points then, so first step is to draw it out. Second step is to count the number of observations. And then that fit in the range, that fit in the range. And then calculate their percent. So within 1 standard deviation, within 1, I'm going to use S to represent standard deviation. We have 43 out of our 60 data points. So if we flip back and look between 140 and 272.9, we would be counting how many fall between 140 and 272. So you're literally just counting, and you find, nope, 316 is not in there, 396 isn't in there, not 46. So, and then 218 is in there, and you would go through this whole data set and just count them up, and you'd get 43. So that would be divide 43 by 60, and we get 71.7%. And then within 2 standard deviations, you get 57 out of the 60, which is 95% of the data if we divide, which is right on. That's exactly what our estimate is. And then within 3, we have all 60 observations within 3 standard deviations, which is very close to our 99.7%. So in part D is when we actually compare the two. We compare our estimate in part B to the actual in part C. And in this case, the empirical rule provides excellent estimates. So we'll say the empirical rule provides excellent estimates of the actual percent. Right, so we're comparing 68% from the empirical rule to 71.7, 95 to 95, 99.7 to 100. It's very close. So we'll do some more practice in these questions here. So question 1 says the data set has a mean of 10. I'm going to draw it out. All right, the mean is 10. And then the standard deviation is 3. So this is pretty easy to just count. And I'm just going to, for the sake of room, write plus S plus 2S plus 3S. So we've got 13, 16, and 19 above the mean. Then we'll subtract 1S, 2S, and 3S below the mean, and get 7, 4, and 1. So approximately 68% of the observations lie between, right? So you're looking for the numbers within 1 standard deviation of the mean, and that would be 7 and 13. And then 95% lie between what 2 numbers? And again, we're looking 2 standard deviations away from the mean, so that would be 4 and 16. And then finally, 99.7%, you would go all the way out to 3 standard deviations, so between 1 and 19. Similarly, question 2, you have that data set with a mean of 25. So helpful when we write it out, draw our little table here. 25 and then plus S, 2S, and 3S above the mean. Our standard deviation is 5, so we're just doing 25, 30, 35, and 40. And then 3 standard deviations below the mean, minus S, minus 2S, and minus 3S. So we're dropping down 5, down to 20, 15, and 10. And again, this starts to become pretty quick and easy when we do 68% are within 1 standard deviation, 95% would be within 2 standard deviations, and then 99.7% of the data we would expect to find between 10 and 40. Question number 3 says the data set has a mean of 15, standard deviation of 2, and this is just asking us for what percentage would lie between 13 and 17. So if we draw that one out, with the mean being 15, and if we go to one S above, we're at 17, and one S below, we're at 13. Adding and subtracting 2. So we're already there. So we know that that would be 68%. Similarly, we have in question 4, the mean we have a mean of 30 and a standard deviation of 4, and we're looking for between 22 and 38. So we have 34, 38, and there we got it on the top side. And we have minus S and minus 2S below. We'll go down. 4 would be 26 and 22, and that's where we found our numbers 2 standard deviations away, which is 95%. We estimate the data would fall within that range. Data set has size 40, so this one's a little bit different. Size 40. How many actual observations would we expect to lie within 2 standard deviations to either side of the mean? So 2 standard deviations is 95% of the data. So we just take and multiply 90.95 times our size of our data set, and we get 38. So 38 observations would lie within those 2 standard deviations of the mean. And you could do the same, would be same process for number 6, and 7 is the same idea, as well as, let's see, 1 standard deviation. Yep, 8's the same idea. Now 9 is a different type of question, so we'll look at that one. It has 80 observations. The mean is 30, standard deviation is 5. So how many observations will we expect to lie between 20 and 40? So this is one where it would be helpful to draw it out. Our mean is 30. If we add our standard deviations, plus 2S. So we're adding 5 each time, so 35, 40, and there you see it. We hit 40 within 2 standard deviations. So that, let's see below, minus S, minus 2S, minus 3S. We have 25, 20, and 15. So between 20 and 40, 95% of the data would fall between there, we would expect, approximately. So again, we're doing 0.95 times 80 observations. So that would be 76. 76 observations. So then the data set has 250. Here's the mean, here's the standard deviation. And again, same process as number 9. I believe this is also the same process, and same process as number 9. So you should be able to do all of the examples there, and that was 3.3, the empirical rule.